Hello everyone, and welcome back to the series where I build a graphical text editor from the ground up, starting from just the terminal. Today I'm going to be writing a simple text buffer. Now the topic of text buffering is pretty massive. There's a lot of different ways of doing it, and so I'm going to just talk about a few simple text buffers instead of going into that topic all the way. I'll explore it a bit more thoroughly in the future. So for a basic editor, as I've shown you before, even just a basic string will do the trick. And in fact, that can scale up to files as big as 10,000 characters and still be pretty usable. However, I am going to be using a split buffer for this next iteration of the editor. You may also know about it as a gap buffer. Now, a gap buffer is simply an array where all the characters that precede the cursor are placed at the beginning of the buffer, and all the characters that come after the cursor are placed at the end. So in a string buffer, one of the problems is whenever you insert a character, all of the following characters have to move to accommodate the inserted character. In a split buffer, all the following characters have already been moved as far as they can go, and so there are no characters that have to be moved whenever you're inserting a new one. And this works all the way up until you've filled the split buffer, at which point you'd probably reallocate and create a new one that's larger. So having this particular weakness of the string buffer fixed means that it is much more efficient under the vast majority of conditions. And the only time you really need to move characters around is when you move the cursor. Now there are some limitations. Things like multi-cursor operations are really complicated to deal with, but that's for a much later discussion and it's not going to be applicable for quite some time. So with that, let's just take a quick look at the code. So as you can see, I have created a class called TextBuffer, and that has, constructor, destructor. This thing loads the buffer, and then we have this advance and retreat function, insert, remove, and then print is replacing the print function in the run loop currently. Now, the text buffer itself only really needs 4 member variables, in this case, an array to store the data, a capacity to tell us when the data storage is full, or how much data storage there is, and then a precursor index and a postcursor index. Now, precursor index is they're both pretty self-explanatory. Basically, the precursor index is pointing at the next space just past the last character before you reach the cursor. So it's pointing to an empty space. And then the postcursor index is pointing at the character that is just past the cursor. And at the start here, the postcursor index isn't actually pointing at anything valid. And I'll go and show you guys that by moving over to the source file. So in the source file, these constructor and destructor are pretty standard, nothing too particularly complicated. In the load buffer, when we start this, all this is hard-coded to 4 kilobytes of space. That's something that I will change in the future, but 4 kilobytes is plenty for most files that I'm going to be working with for now. And then the precursor index is set equal to the length of whatever data we load in. So it's going to be pointing just past the first piece of data because all C arrays are based on 0 indexing. And then the postcursor index is set to 4 kilobytes, and so it's currently pointing at nothing valid. And then as soon as we move the cursor back once, it will start to point at a valid character. And so if we look at something like this retreat function here, both advance and retreat are pretty similar. In this case, advance checks if the postcursor index plus the distance we want to travel is greater than the capacity, and if so, it will fail. Now in this case, distance isn't going to be able to be anything other than 1. If it's anything other than 1, it's not going to change anything. But in the future, I will make sure that this can move distances greater than 1, because otherwise you have to repeatedly call the function. That's just kind of annoying. So in this case, we copy the data from the postcursor index, to the precursor index, and then we advance the 2 indices. And then return 1. In retreat, it's very similar. If the precursor index minus the distance is less than or equal to 0, then it returns 0. Then also we have the precursor index and the postcursor index being decremented, and then the data from the precursor side of the buffer being copied over. Now on to insert and remove. Because of the way the buffer is set up, insert and remove are both very simple. In this case, it's just taking in a string, which again, in this case, it's only going to be able to deal with a single character for the moment, but that is going to be changed in the future. So in this case, the validity check is, does the precursor index equal the postcursor index? If they equal each other, that means that this thing's full, so we can't insert anymore. And so if it's not full, then we'll place the data at the location where the precursor index is, and then advance the index and return 1. And remove is actually a lot easier because we don't even need to change the data there. We just reduce the index by 1. We decrement it. Because if it's not pointing to the data, then we just don't know that that data exists. And then finally, the print function. It's pretty simple. I'm using fwrite because that way I can limit based on a number how much I'm writing, how much data I'm writing to standard out, rather than having to use something that's null terminated. If you use something that's null terminated, that's going to make things more complicated. And then if the postcursor index is equal or is less than the capacity, then we print what's in the postcursor index and then flush the output. And so now just looking really quickly at main. In this case, I've went ahead and tied in the text buffer into the setup. And I just went ahead and did a couple simple operations. So we retreat twice and then remove one of the characters and replace it with Q. And then also I replaced the printing in here with the printing from the text buffer class, the print function. And so now if we look at this test file that I created, it's got some stuff in it. I believe that supercalifragilisticexpialidocious is actually misspelled, but I'm not going to bother changing it. Now if we run the function, you'll see that the U here that was near the end of the supercalifragilisticexpialidocious, that's been replaced with a Q because we removed it and then replaced it with an inserted Q. So it seems to work. This isn't very extensive testing, but it should be good enough to move on. And you might be curious why it is that even though I moved back twice, it only seemed to have moved back once. That's because that's not including the new line, because this has a new line at the end. So new line character, then moves to the S and then to where the U was and replaces that. So that kind of threw me off at first, but that does seem to work. And so that's basically it. So now I have a working text buffer. In the next episode, I'm going to be tying everything together, so hopefully by the end of it, I will have my next text editor. Thank you very much for watching, and I hope you found this interesting and or useful, and I'll see you in the next episode. Goodbye.